Good morning, students. My name is Amit Goel. Today I am going to teach you the subject theory of automata and formal language. We have the subject code KCS 402. The books which we can refer for this, that is the number 1 is the KLP Mishra, number 2 is the Hopcroft, Ullman, Motwani, and the third one is the Miguel Sipser. We have 3 books we can refer for that. Now the first unit is basic concepts of automata theory. So automata theory, what is automata theory? It is also known as theory of computation. So automata theory is a theoretical branch of computer science and mathematics which mainly deals with the logic of computation with respect to the simple machine referred to as automata. Now why study theory of computation? What is the need of studying the theory of computation? The theory of computation is used to help develop mathematical and logic models that runs efficiently and to the point of halting. Halting means at which time the machine will stop. So each and every machine has to be halt. Why should we need to learn theory of computation? As you know, theory of computation is very important as it helps in writing efficient algorithms that operate on computer devices, research and development of programming language, and in compiler design. So here we have so many areas where we can use the theory of computation. We can use it in the compiler design, in the research, in the algorithm making, and where we can use the automatic theory of computation, that is automatic printing machine, automatic photo machine, card punching machine, vending machine, human detection, ATM machine. There are so many examples where we can use the theory of computation. Now we are going to start the unit 1, basic concepts of automata theory. These are the some terminologies that we can use in the theory of computation. So these are the basics you have to understand very carefully. Number 1 is symbol. What is a symbol? A symbol is the smallest building block which can be any alphabet or letter, and the symbol is also called as the character. It can be any A, B, C, any alphabet and numeric 0, 1 in the lower case and the uppercase as well. So we have some alphabets over there which is denoted by the symbol summation. Here we can see the symbol. Alphabets are a set of symbols which are always finite. So what is alphabet? It is a set of symbols. We have some symbols and these symbols are always finite. That means we can calculate the total number of symbols. Here we have the example summation equals to 0, 1, which is an alphabet of binary digits because we have 2 digits over there. Now another set is summation equals to 0, 1, 2 up to 9. It is an alphabet of decimal digits. Here also we can have the summation equals to ABC, the characters, the alphabets in the lower case, or we can use the summation equals to ABC in the uppercase as well. So we have different type of alphabets and it should be by finite. Now what is the string? A string is a finite sequence of symbols for some alphabet. I am repeating again. A string is a finite sequence of symbols for some alphabet. A string is generally denoted as W. So by the symbol W we can denote the string, and if we want to find the length of the string, that we have the mod of W. So we have some symbol, some string W of any length, and we want to find the length of the string, that will be represented as the mod of W. Also empty string is the string. Here we can define the empty string is the string with 0 occurrence of symbols. In the empty string we have the occurrence of symbol is 0, and the empty string will be represented as the epsilon symbol. Here we can see the epsilon symbol is there, right? Now we have some examples out there. Number of string of length 2 that can be generated over the alphabet A, B. So length 2 के कितने आपके strings बन सकती है? That are AA, AB, BA, BB. Although with the combination of A and B, we can have n number of strings, or we can say infinite number of strings. But the length of 2, in which the length of 2, we will have only 4 strings, that is AA, AB, BA and BB. Now the length of string is W, mod W equals to 2. So number of string will be 4, as we see in the previous slide. Now what is the conclusion? For example, if we have AB is the set of symbols with length n, so number of strings that can be generated by these alphabets is 2 raised to power n. Note, if the number of symbols in the alphabet summation is represented by the mode of summation, the number of string of length n possible over summation is mod of n raised to power n. Right? Now we have some closer representation in theory of computation. Number 1 is the L plus. What is L plus? L is some language, and it is a positive closure that represents a set of all strings except null string or epsilon string. So what we can see over here, L plus, it is called as the plus closure on some language L. So L plus is a positive closure that represents a set of strings except null. It means we cannot have the null value over there, or we cannot have the symbol epsilon which have 0 occurrence of symbol. Right? It means in L plus we will have the string of length at least 1. It can be 2, 3 and so on. And now the L star, it is called as the clean closure or clean star that represents the occurrence of certain alphabets for given language, alphabets from 0 to infinite number of times. So in the L star or the clean star, we can have the strings of length 1, 2, 3, 4 and so on, and also we have to include length of 0, that is called epsilon, or null string we have to include in the L star. So we have two type of closure. Number 1 is the L plus, and second is the L star. Right? L plus is called as the clean plus and L star is called the clean star closure. So from the above two statements, we can conclude that L star will be equal to the null string union L plus. अगर हम L plus के अंदर, in which we will have the string of length 1 to infinite, and if we have add the null string also, then it becomes the L plus. What is the formula for that? L star equals to null union L plus. Right? Now we'll move to the next topic, that is called language. A language is a string chosen from some summation star, or we can say a language is a subset of summation star. In summation star we have all the language, right? So we have to choose some particular language that we have to choose from the summation star. So we can say a language is the subset of summation star. A language that can be formed over summation can be finite or infinite. तो जो लैंग्वेज हम लेंगे इसके अंदर वो आपकी फाइनाइट भी हो सकती है और इनफाइनाइट भी हो सकती है. Here we have some examples of finite language. तो पहले हम लेते हैं L1, in which we will have the set of string of 2. It means इसके अंदर जो लेंथ होगी वो केवल 2 लेंथ की होगी. For example, if we take the summation equals to x, y, we can have the strings xy, yx, xx and yy. Right? So here we can see the example. Example of infinite language. We can have the L1, some language, set of all strings start with B. So ऐसी कितनी स्ट्रिंग हो सकती हैं जो B से स्टार्ट हो सकती हैं, जिनके अंदर A B का कोई भी कॉम्बिनेशन होगा. So B से स्टार्ट होने वाली आपकी हो सकती है BA BB, BAA, BA, BB, BBB, BAAB। सो ऐसी इनफाइनाइट नंबर ऑफ स्ट्रिंग आपकी हो सकती है जो आपकी B से स्टार्ट हो सकती है। ठीक है, तो वी हैव द टू एग्जांपल्स, डिफरेंट एग्जांपल्स, वन इज फॉर द फाइनाइट लैंग्वेज एंड सेकंड वन इज फॉर द इनफाइनाइट लैंग्वेज। Also we have some more examples here. The language of all string consisting of n zeros followed by n ones for n equals to 0, 1. So we can have epsilon, we can have 0, 1, 0, 0, 1, 1, 0, 0, 0, 1, 1, 1 and many more. So this is also a set of the infinite string. Number 2, the set of strings over zeros and 1 with equal number of each. So in this example what we can say, in the previous one the language consists of n number of zeros followed by n number of ones. तो उसमें पहले 0 आएंगे, n number of 0 आएंगे और फिर n number of 1 आएंगे. In the second example also we have the same number of 0 and 1 but the sequence may be changed. It can be 0 1 and 1 0, 0 0 1 1, 1 0 1 0. Here we can see दोनों के अंदर number of 0 and number of 1 are same in the both the examples but with different strings, right? Number 3, the set of binary numbers whose value is prime. तो ऐसा हमें सेट बनाना है जो प्राइम नंबर को आपको लेता हो लेकिन we have to represent in the binary. तो ऐसे कौन कौन से नंबर है? 2 है तो we can represent by 1 0, 3 है we can represent by 1 1, 5 है, 7 है, 11 है and so on. Number 4, 5, the empty language. It is also a language, right? And number 5 is epsilon. The language consists of only the empty string. Here we can note the phi is not equal to null because phi has no string and null has one string of length 0, right? तो phi के अंदर हमारा कोई भी string नहीं होगी, null के अंदर एक string होगी जिसकी length 0 होगी. That we have to understand. They are not equal. Now language in the set forms. When we define the language in the set form, we have to give the some string and we have to give the logical view about that W, right? For example, L equals to W, where W consists of an equal number of zeros and ones. तो W हमें क्या बता रहा है कि जो 0 और 1 आएंगे वो आपके इक्वल नंबर में आने हैं. उनका पैटर्न कुछ भी हो सकता है, उनका सीक्वेंस कुछ भी हो सकता है, लेकिन एक चीज ध्यान रखनी है कि 0 और 1 इक्वल नंबर में होने चाहिए. नंबर 2, L equals to W such that W is a binary integer that is prime. तो ये हमने देखा था पिछले एग्जांपल के अंदर. इन द प्रीवियस एग्जांपल वी हैव सीन दैट वी हैव द स्ट्रिंग्स 1 0 1 1 1 0 1 1 1 1 and so on. Also we have the some one more language, L equals to a raised to power n b raised to power n such that n is greater than equal to 1. So how we can define that particular language in the words? We can define, we'll have the n number of a's followed by n number of b's. पहले n number of a आएंगे, उसके बाद n number of b आएंगे, जहां पे n की वैल्यू कम से कम 1 होगी, should be greater than equal to 1. So what will be the strings of that particular language? We can have AB, AA, BB, AAA, BBB and so on, right? Now we'll move to the next topic, introduction of finite automata. What is the finite automata? How will we define the finite automata? Finite automata is the simplest machine that is to recognize the patterns. कोई भी पैटर्न होता है तो उसको रिकॉग्नाइज करने के लिए वी कैन यूज द फाइनाइट ऑटोमेटा. इज द सिंपल मशीन दैट वी हैव. द फाइनाइट ऑटोमेटा और फाइनाइट स्टेट मशीन इज एन एब्स्ट्रैक्ट मशीन दैट इज 5 एलिमेंट्स और टपल्स. तो फाइनाइट ऑटोमेटा के अंदर क्या कैसी मशीन है जिसके अंदर 5 एलिमेंट्स होंगे एंड इन द टेक्निकल लैंग्वेज दिस एलिमेंट्स आर कॉल्ड एज द टपल्स. तो हम टपल्स ही बोलेंगे, ठीक है. So finite automata is a machine which have 5 tuples. It has a set of states and rules for moving from one state to another but it depends upon the applied input symbols. एक स्टेट से दूसरे स्टेट में जाना है and we have to apply the some input symbol. When on the machine, we will apply some input symbol, we will reach to the next state and we will have some output. So here we have the n number of input is there, we have to apply on the machine state of automata. In the state of automata, we will have n number of states represented by the q1, q2 and qn, and we have the n number of outputs will be there. So जब मशीन के अंदर ऊपर हम अप्लाई करेंगे इनपुट को, we will have the output. So this is the model of the finite automata. So we were discussing about the tuples. A finite automata consists of the 5 tuples. Number 1 is the Q, which is the finite set of states. More specifically, we define Q, it is non-empty finite set of states. Why it is called non-empty? Because the set of states cannot be empty. कम से कम हमारे पास एक स्टेट तो होगी ही, so it cannot be non-empty finite set of states. Second is summation, the set of input symbols. Again, it is also non-empty finite set of input symbols. Q naught is said to be the initial state. जो पहली स्टेट होगी, that we will represent by the Q naught. F is the non-empty finite set of final states. तो जितनी भी फाइनल स्टेट्स होंगी वो सारी की सारी कहां पर रहेंगी, हमारी F के अंदर रहेंगी. डेल्टा इज द ट्रांजिशन फंक्शन. ट्रांजिशन फंक्शन क्या बताता है हमें कि जब हम किसी स्टेट पर है और वी अप्लाई सम इनपुट ऑन दैट स्टेट, व्हाट विल बी द नेक्स्ट स्टेट, कि हमें कहां जाना है इनपुट सिंबल को अप्लाई लेने के बाद. सो हियर वी कैन कैटेगराइज द फाइनाइट ऑटोमेटा इन द टू टाइप्स. So number 1 is the deterministic finite automata. It is also called as DFA. DFA consists of 5 tuples: Q, summation delta Q naught F, and the tuples are same. Q is the set of all states, summation is the set of input symbols, Q naught is the initial state, F is the set of final state, and delta is the transition function. So here we have to define the delta over there, that is Q into summation tends to Q. It means when we apply some input symbol on some state, we will have some unique state Q. Right? So here we can define the number of states or number of tuples in the deterministic finite automata, or in the short DFA. In a DFA, for a particular input character, the machine goes to one state only. That is why it is called deterministic. What is the meaning of deterministic? When we apply some input symbol on some state, the next state will determine uniquely. यानी कि वो केवल एक ही होगी, वो एक से ज्यादा नहीं हो सकती है. So in the DFA, for a particular input character, the machine goes to one state only. A transition function is defined on every state for every input symbol. तो DFA के अंदर हर स्टेट के ऊपर जितने भी इनपुट सिंबल हमारे पास होंगे, we have to apply all the symbols on each and every state. Also in DFA, null move is not allowed. यानी कि we cannot apply the null string in the case of DFA. Because that is why DFA cannot change state without any input character. तो DFA के अंदर जब तक कोई इनपुट कैरेक्टर नहीं जाएगा, वो अपनी स्टेट को चेंज नहीं करेगा. Here we can see the example over there. DFA with summation equals to 0, 1 except all strings ending with 0. This is called the state diagram. Here we can see it is called the state diagram. The initial state will be represented as the incoming arrow. जो भी आपकी initial state होगी उस पर हम incoming arrow show करेंगे, तो we'll consider it as a initial state. And for the final state, we have to use the double circle. दो सर्किल के साथ हम फाइनाइट स्टेट को रिप्रेजेंट करेंगे अपने स्टेट डायग्राम के अंदर. So what is the language over there? We have to design the machine accepts all strings ending with 0, 1, and we have two symbols. So here we can see if we apply 0, we can move to the final state. यानी कि 0 आपकी एक्सेप्ट होनी चाहिए. यहाँ पर अगर कोई भी ट्रांजिशन लेने के बाद वो फाइनल स्टेट पर रुकता है, तो वी कैन से इट इज द एक्सेप्टिंग स्टेट और एक्सेप्टिंग स्ट्रिंग। 1 अप्लाई करेंगे खाली तो एक्सेप्ट नहीं होगा, 1 0 अप्लाई करेंगे तो खाली एक्सेप्ट होगा बिकॉज इज द वैलिड स्ट्रिंग, 0 0 अप्लाई करेंगे तो एक्सेप्ट होगा, 0 1 करेंगे तो नहीं होगा बिकॉज इट इज द इनवैलिड स्ट्रिंग। सो अकॉर्डिंग टू द गिवन लैंग्वेज वी हैव टू डिजाइन द DFA. One more important thing is to note there can be many possible DFAs for a pattern. एक ही लैंग्वेज के लिए हमारे पास मल्टीपल DFA हो सकते हैं, we can have multiple DFA for the same language. But what we will consider a DFA with minimum number of state is generally preferred. तो जिस भी ऑटोमेटा के अंदर DFA के अंदर मिनिमम नंबर ऑफ स्टेट होंगे that will be the most preferred DFA, right? Here we have some examples of DFA. Design a DFA that accepts set of strings such that every strings end in 0 0 over alphabet 0, 1. अब इसका DFA बना के देखते हैं। What is the question? Every strings ends in 0 0. So first of all we have to take the initial state. So we will represent initial state as Q0, and what I told you, we have to give the incoming arrow on that particular initial state. Now here we have to end the string which is in 0 0. So what strings can we have? Either it can be 0 0, it can be 0 0 0, we can have 1 0 0, we can have 1 0 1 0 0 and so on. तो यहाँ पे हम देख सकते हैं सारी वो स्ट्रिंग्स आ रही हैं जिनके अंदर एंडिंग 0 0 से हो रही है, जो हमारी लैंग्वेज को बिलोंग करता है। So what is the length of the minimum string over there? That is, the length is 2. This is the minimum string having 2 0 and the length is 2. So what is the logic behind to making the transition diagram? We have to use at least 2 more states, right? So first design Q1 and Q2, apply the minimum string 0 over there and 0 over there. So this 0 0 will be accepted by the machine. So we have to make Q2 as the final state by using the double circle. So this is a minimum machine. Now we have to complete all the zeros of each and every state and all the ones on each and every state. So Q0 का 0 is going to Q1, the 0 of Q1 is going to Q2, and अगर हम Q2 का 0 भी यहाँ पे रखते हैं तो there will be no problem, क्योंकि 0 0 के बाद 0 तो आ ही रहा है. So this is no problem. Now we have to check the number of ones, कि 1 जो होंगे Q0 पे अप्लाई करने पे कहां जाएगा, Q1 पे अप्लाई करने पे कहां जाएगा, Q2 अप्लाई करने पर कहां जाएगा. तो 1 अगर हम Q0 पे अप्लाई करते हैं तो उसका 1 हम यही रखेंगे, बिकॉज ये हमारी लैंग्वेज को डिस्टर्ब नहीं करेगा, हमारी लैंग्वेज को ब्रेक नहीं करेगा. ठीक है, तो Q0 का 0 1 अप्लाई हो गए हैं. अब Q1 का 1 हमें अप्लाई करना है, तो Q1 का 1 कहां अप्लाई करे जिससे कि हमारा लैंग्वेज डिस्टर्ब ना हो. तो यहां पे करते हैं तो 0 1 0 ले लेगा, दैट इज नॉट वैलिड स्ट्रिंग. यहां करते हैं तो 0 1 ले लेगा, दैट इज अगेन नॉट अ वैलिड स्ट्रिंग. सो वी हैव टू मूव ओवर हियर, द 1 शुड बी ऑन द Q0 state. Okay, now what about the 1 of Q2? So again with the same reason, that will go to the initial state Q0. So this is the final automata, that DFA for the given language, accepting 0 0 as the minimum string, right? Now here we have to define the tuples. What are the tuples? The tuples are, if M is the name of the machine, we can have Q summation delta Q0 F. Here we have to define Q, in the Q we have Q0, Q1 and Q2. We have 3 states in Q. In the summation we'll have 0, 1, where Q0 is the initial state. Here we can see Q0 is the initial state. F is the set of final state. So here we have only one final state is over there. Now we have to define the delta, that is called the transition function. Transition function. So how we will define the transition function over there? We have to define the transition function like delta Q0 comma 0 will be equal to Q1, delta Q0 comma 1 will be equal to Q0, delta Q1 comma 0 will be equal to Q2, delta Q1 comma 1 will be equal to Q0, delta Q2 comma 0 will be equal to Q2, and delta Q2 comma 1 will be equal to Q0. So this is a transition function. This transition function we can show in the transition table also, right? So how we have to make the transition table for the given transition function? So first I will erase, then I will show you the transition function, how we will design the transition table for the given language. So we have transition table. Here we have the state, we have the input symbol. How many states we have? That is 3 states, Q0, Q1, Q2. And what are the number of input symbols? Input symbols are 0 and 1. So here, sorry, this is the initial state. So for the initial state in the transition table, we have to use the incoming arrow, right? And for the final state in the transition table, we have to use the star to represent initial state and the final state. So at Q0, 0 on Q0, we will move to the Q1. And when we apply 1 on Q0, we will remain same on the state Q0. Similarly, for 0 on Q1, we will move to the Q2 state. And when we apply 1 on Q1, so we will move to the state Q0. When we apply 0 on Q2, we will remain on the state Q2, and after applying 1, we have to go to the state Q0. So this is called the transition table, right? Either we can have the language, or we can have the diagram, or we can have the transition table. कोई भी एक चीज हमारे पास है, हम बाकी 2 चीज को डिजाइन कर सकते हैं. So this is something about the today's topic DFA. Thank you very much.